All right, welcome. We are going to talk about Java 9, and specifically we're going to talk about the modularity system coming in Java 9. So, of course, Java 9 is not just about modularity. There's a bunch of things coming, a few interesting things. For example, there's HTTP2 support. But by far the largest new thing coming to us is the module system. And since it's a pretty big topic, that's what we're going to focus on. There's one more reason that we're going to focus on this topic, and that's because Sandra and I are writing a book about it. So that's why we got started with this whole topic, and well, that's why we are here to talk about it. So my name is Paul, this is Sander, we're both from the Netherlands, and we work for a company called Luminous. And if you look at Luminous and what we're doing, you will see that modularity is quite of a big theme for us. We've been working with OSGI for a long time. I've published a book about OSGI a few years ago. And not just because we like OSGI that much, but mostly because we think at an architectural level, at the design level, modularity is a very important concept. And well, that's good news for Java 9 because Java 9 will bring us much stronger support for working with modules. So first of all, we're going to look a little bit at the problems that we currently have with Java when it comes to modularity. We will see why modularity is important as an architectural principle. And then we will dive right in and look at quite a bit of code that will show how to actually work with Java 9 modules, because that's probably the most important part. We will also talk about services, which is a, well, kind of an existing old concept in Java, but probably most of you don't really know about it, and it's kind of getting a new life in Java 9. We will look at linking, and finally we will start looking at how to migrate existing code to this module system, because, well, it's nice if you can write new applications with modules in mind, but it would be even better if we can actually take our existing code bases and migrate them to the future. But first of all, why do we even care about modularity? Well, something that I often say is that modularity is the ultimate agile tool. The reason for that is that, well, if you don't have a proper modularized code base, we all kind of know the problems with that. Once you get started with a project and the code base is relatively small, it's very easy and very fast to make changes and to implement new features and maybe take some features away. But after maybe half a year, it starts to be a little bit more painful. You make a change somewhere just to add some new feature or fix a bug, and something on the other side of the system that you completely didn't expect falls over because there was some kind of unexpected dependency between those pieces of code. And we don't really have the tools to know about that. If you have a modular code base, it becomes much easier to reason about what the impact of a change might be. Because we can very easily verify that if you make a change in one module, that it can't affect, well, other pieces of our code, other pieces in our code base. So that's why we believe this is very important. And if you look at what modularity is actually about as a principle, it's all about encapsulation. So what we would like to express in our code base is that we have some code working together, doing something useful, and we would like to draw a box around that code and say, well, this is a module. And other modules in my system, other code in my system, shouldn't really care or even know about how I implemented that feature. That's all implementation details, and I should be able to just freely change those implementation details without anyone else noticing that. The only thing that I want to share with others, share to other pieces of my code, should be a service contract. More concretely, in Java, probably an interface. You want to share your API, but you shouldn't share your implementation. Because if you do share your implementation, well, it's very easy, even by accident, that someone else starts using your implementation without even knowing it. And when you make changes to that implementation, well, you introduce problems for that other person. Especially if you start working with a large code base and several people on a team or even a larger team, that starts to be very, very problematic. There's a problem in, well, Java currently, because we don't really have this whole concept of a module. Yes, we have jar files that kind of looks like a module, but in the end, it all ends up at the flat class path. And that means that all the classes that we have, either in jar files or outside of a jar file, they will just be thrown on a big heap. And once we load a class, well, it's just a scan from left to right. And when we find a class, that's what we start using. There's no concept of a module anywhere. And of course, we do have the public, private, protected modifiers in the Java language. But probably we all know that, well, that's not a strong enough concept to reason about modules. Because when you have a few classes working in different packages together, which is very reasonable, you kind of have to make most of that code all public, because otherwise, well, Java just doesn't work. It wasn't designed to be used as, well, kind of a module system. So we need something better. And that better thing is coming with Java 9. In Java 9, we will have a module system. But this module system is, of course, not completely finished yet. Java 9 is still scheduled to be released in March 2017. That means that we are getting close to a code freeze and getting close to finalized specifications. But we're not quite there yet. So probably most of the things that you will see today will still be true in a year's time, but there might still be some changes coming. Looking at Java 9, there's a few goals that the JDK team tries to resolve. First of all, they took a good look at the JDK and they realized that, well, it's huge. There's just a lot of stuff in there, and there's also a lot of stuff in there that a lot of people don't actually use anymore. Because, well, Java is around for quite a long time. There's been technologies coming and going, and, well, they ended up in the JDK. And it's very difficult to actually take something out of the JDK. Even stuff like Corba, for example, well, it's still in there because there are still some very unlucky persons using that. But that means that, well, they can't really take it away. And that means that JDK is just growing and growing and growing, which is, well, problematic if you start using it, especially on smaller devices. So they wanted to cut up the JDK itself in modules, so that if you just want to write hello world, you don't have to drag in the complete JDK with all those modules in there, but you just need maybe a Java base module or something like that. Something very small, very lean, and that's all you need from a runtime perspective if you want to write something very simple. So that's very good. The second goal, and that's probably even more interesting to us as developers, is that we will also get a module system that we can use ourselves in code. So the Java language is going to be changed. It's going to be getting some new concepts to start working with modules. And this will actually be exactly the same module system that they used to split up the JDK itself. So they used it internally for the JDK, but we will get access to the same mechanisms to split up our own code bases. And that's probably what we're going to see most of the time. There has been a prototype for quite a while now. That prototype is already merged into the main Java 9 code base. So if you download a Java 9 preview today, Jigsaw, the module system, is already part of that. And it also kind of means that there's no way back anymore. Because they did merge it to the main code base, they're probably, they will take it to the Java 9 release, which is good news for us, I guess. And it's about time because, well, there's been talk about module systems in Java for over 10 years. As early as 2005, there was a JSR, a specification, about a Java module system with ideas to add a module system to the Java language. Well, that obviously never happened. Until Java 7, because, well, Jigsaw, as the whole system was renamed, was supposed to be released in Java 7. And there was a prototype, it kind of worked, and, well, people were expecting this will actually end up in Java 7. Up until the point that Oracle bought Sun. And, well, things slowed down quite a bit. They lost a lot of time there. And they couldn't actually finish that prototype to, well, something that was ready to be released for the Java 7 release, because that release was already, well, not making the timelines. So they made the decision to take the module system out and move that to Java 8. And of course we know, well, once again in Java 8 it was just not finished. and I took it out again. But as I said, it's now all part of the main Java 9 code base, and it probably means this time is actually going to happen. This is a picture of the module graph of the JDK itself. And well, if you just see that on a slide, it kind of looks horrible, doesn't it? And that's because, well, as I said, the JDK is pretty big, and that means there's a lot of modules. You don't actually have to remember all this stuff or even understand it, but there's a few things that you will see here, and that's at the bottom we have a Java base module. And that contains stuff like Java lang, so Java lang object, for example, is there, and the collection classes are there. And it also means that if you write an application that just uses those kind of core constructs of Java, that's all you need. And that's a very small subset of the complete thing. That also means if you don't use certain things, well, you will just not have to drag them in if you ship your application. And that's very good news. The other thing that you might notice is that all the arrows are actually pointing to one direction. There's no cycles in there, and well, that's probably good because cycles are not supported in Java 9. So you can't have cycles in modules, which is, well, again, good news, because cycles don't really go well with modularity as a concept again. It's always a bad sign if you have cycles. So that's pretty good. But more importantly, there's going to be a big chance for us as developers again. And that's that the class path is going to disappear. That doesn't mean that the class path is gone in Java 9. You can still run your applications as you would do today, using the class path in Java 9, but then you're not really using the module system. If you start using the module system, as we will see later on, the class path will actually not be there anymore, and we start talking about a module path. And Sander will tell us all about that. But this is great news, because the class path isn't really, well, our favorite thing when it comes to Java, I guess, because it's just completely unreliable. Maybe your build tool specifies what kind of, well, dependencies you have, and that results in a class path. But that class path can't be verified. There's classes on there, sure, but are all the classes on there? Am I missing anything? Well, who knows? Looking at a list like this, there's no way to tell that. Are there conflicts? Do I have two versions of SLF4J there, which might break at runtime? I don't know. There's no way to verify that, just looking at this kind of class paths. So we definitely need something better than just a flat class path, and well, that's going to be the big chance and the big game changer in Java 9. Because what we will get with Java 9 is a way to actually express modules. We can define modules, and even more important than that, we can define dependencies between modules. So we can express at the Java language level that my module requires some kind of other module. And both at compile time and runtime, we can verify, are all my dependencies satisfied? Is everything there? And that's, well, that's so much better than just a flat class path where stuff might or might not work at runtime, and you probably never know until you see it crash. The other thing that we get in this concept of modules is much stronger encapsulation. We can now define in a module which parts of my code should be visible to the outside world, should be exported, that's probably just my API, and which part of my code is completely encapsulated and invisible to other modules. And you can already see this in the JDK itself, because there's a whole bunch of packages in the JDK that are implementation packages, everything that's com.sun and sun.star, etc. And you're not supposed to use that in your own code. But, well, there's not really any way to, well, first of all, tell that right now, besides looking at the documentation. And people have been using those classes quite a bit, of course, in the past. That will change in the future, because that's just not possible anymore. Those classes are completely encapsulated, and you just can't access them anymore. One exception, and that's sunmisk unsafe and a few other classes like that. They were actually supposed to encapsulate that as well, until people started complaining quite a bit that, well, that would break most of the libraries out there, because a lot of libraries are using sunmisk unsafe. You could say, well, they shouldn't do that, because it is, after all, an implementation class, a dangerous implementation class even. But because there's not really an alternative to do the things that you can do with unsafe, they decided, okay, until we have a better alternative, we will actually export it, we will make it accessible to people that want to use it, so that we don't break half of the world, and that's probably a good decision. Then, before we dive into the code, one more question. Because why not just use OSGI? That's a question that, well, especially OSGI users ask quite often. And, well, I'm an OSGI user myself, so that has been a question that's been on my mind as well. Well, first of all, looking at the goals of Java 9, they also wanted to modularize the JDK. That's how it all started. And you can't really modularize the JDK with technology built on top of the JDK. Because at the end, OSGI just relies on the class path like any other Java library. So technically, that just doesn't make any sense. But then, of course, you could say, well, great, modularize the JDK as you see fit, dear JDK team, but don't bother us with it. If you want modularity in the Java language, we'll just use OSGI, because that's been a solved problem. And of course, that's a fair point. I mean, you can easily have this discussion both ways. You can defend both ways. But even for someone like me who actually quite likes OSGI and write books about it, etc., I can't really deny that OSGI never has seen mass adoption. And that's because it's always this extra thing. And that means that tool vendors and library authors never really care about it the way they should be. Because, well, some people are using it, but most people are not. So what do you do if you're a library author? Is OSGI the first thing on your mind? No, probably not. Very understandable. But with Java 9, this concept will actually be part of the Java language, and there's just no way around it anymore. And it means people will have to deal with the problems, well, that it might bring. And that's probably good news. All right, it's time to look at lots of code. So Sander, take it away.
Yeah, okay, Paul. So I agree, it looks nice in theory, but how does it work in practice? So let's look at some examples. First of all, I'm going to give a little bit of context of the examples that we'll see. So we have a small application called Easy Text, and the idea is that you can read in a file containing text, and that you can run some kind of algorithm over the text that determines its complexity and then gives that as an output. So it's fairly easy. And we'll start out with a simple implementation using 2 modules, just to see how the basic mechanisms of modules work before we move on to a much more advanced example. So in this case, we have a command line interface, the CLI module on the top, and it's going to read in the file, and it's going to need some kind of analysis algorithm. And that analysis algorithm lives in the analysis module. So naturally, we have to have some kind of relation between those 2 modules. And Paul already said the Java module system will actually allow us to express that in the language itself. So let's switch to the code. So what we have here is, it's not an Eclipse, it's not IntelliJ, it's not NetBeans, it's just a text editor, Atom in this case. And I do this for 2 reasons. Currently, the IDE vendors are working on Java 9 support and support for the module system as well. But it's not quite there yet. So in the end, for example, NetBeans will be the reference implementation for Java 9 IDE support as well, but they're still working on it. So that's one reason to just go back to the basics and just use a text editor and the Java compiler and Java command directly. And it's also to illustrate the changes that have been going on. So if we use the Java compiler command directly, we can actually see what's happening and what has changed. So as you can see, I have a source directory, and instead of having the nested hierarchy here of a single package hierarchy, we have 2 modules here. So there's the Easy Text Analysis module and the CLI module. And beneath those, we have the typical package hierarchy that we all know, containing the classes. So why is this a module? Well, it has everything to do with the module descriptor that's in there as well. So you can see there's a module info file, both in the analysis and in the CLI module. And if we look at those, they're very trivial. We have a module keyword, we have the name of the module, and there's no body yet. You might be wondering, okay, this module keyword, how does this affect my existing code? Do we have to rename all my variables that are called module or something? Well, fortunately not. So what's going on is that this is a contextual keyword, meaning it's only a keyword in the context of this module info file. And the same goes for any other keyword that I will introduce later in this file. So no need to worry about existing code on that front. So we have two modules here, and the CLI module contains some code to read in the file. That's right here. We're reading it, and we're turning it into sentences. And then finally, we're calling a class called /kincade, which is a particular text analysis algorithm. And we pass the sentences to the analyze method. Now, this /kincade class lives in the analysis module, which is what we would expect. And let's see how it works when we want to try to compile those modules and see what has changed there. So let me open up a terminal. And let's make it a bit nicer. And we're going to change to JDK 9. Okay, there you go. So just to show you, I'm using an early access version of Java 9. You can go to the website of OpenJDK and download it yourself as well. Nothing special about that. But it allows us to play around and see what Jigsaw and the module system is all about. So let's try and compile the code that we have. What's new here that we have a module source path instead of a source path that we can pass to the compiler. And it knows about the module infos, and it knows about the new layout that we have here. So we have two more directories in between. And we're going to provide it with a directory which the compilation output is put into. And of course, we need to pass in all the Java files that we want to compile like you would normally. So I'm just going to use this little trick here and pass in all the Java files to the compiler. So even though I provide all the Java files to the compiler, it's telling me, okay, you're trying to import the /kincade class in your main class, but it's not visible. So what we already saw is that this module info for the analysis module was empty. And if you do not specify anything, by default, everything in your module is encapsulated. So it's not visible to the outside world, even though this /kincade class is public. So that's quite a big change to the access model of Java. The module layer on top of the access modifiers that we already have really modify that behavior. So in this case, what we can do is say, okay, this module exports the Java Modularity easy text analysis package. So what you can provide is a package name, and you could have multiple export statements, so you can export multiple packages from a module, that's no problem. But by doing so, we're actually allowing other modules to see this package and the types inside of those packages. So let's try and compile it again. And still, the compiler is not happy. Why is that? Well, it works both ways, so to say. On the one hand, we have said that we can export this package, but there's no information yet that this CLI package, the CLI module, sorry, is actually using the analysis module. So we need to be explicit about that. And it might seem very annoying, but in the end, it is a really powerful tool to actually structure your code base and to get help from the Java compiler while doing so. So this module imports the other module, Java Modularity easy text .analysis. There we go. And if we try and compile this again, oh, we have some errors still. Let's see what's going on there. It doesn't import, it requires, sorry about that, requires the analysis module. So let's try that again. And finally, we have a successful compilation. And if you look at the output folder, you can actually see that those two modules have been compiled into the same directories that we defined here in the source. and that they compile the classes, but also the modules descriptor carries over into the output. So we have module info available at compile time, but it's also available at runtime. And that is nice because then the Java runtime can actually use the metadata that's inside of the module info descriptor to resolve whatever modules we need for running the application. So if we want to try and run this application using the Java command, usually you would do java-jar, for example, but in this case we're going to do it with new command line flags for modules. And instead of creating a class path, we're going to create a module path. And the module path can contain directories or modules directly. In this case, we're adding the output directory, which contains 2 compiled modules. By the way, you can also package up these compiled modules into jars. And once you include the module info class, then it's a so-called modular jar. But in this case, we're just going to run them in place without packaging them up. So we have a module path, and you might think, okay, what's in the name? Class path, module path, sounds all the same to me, but we'll see that it's quite different. And switching back to the terminal again, we want to run a certain module. In this case, we want to run the CLI module. So let's see, we have java modularity.easytext.cli. Of course, the Java runtime also needs to know which class to run, and since we haven't packaged this as a jar containing a main entry point, we need to define that here as well. So let's say we want to run the main class here as well, cli.main. And once we do that, we actually get our welcome prompt from the application, and it says, okay, please provide a file name as input. But the nice thing that we can see here is that we only talk about the module CLI when starting this application. And if you followed along with the example, you see that it contains an explicit reference to the analysis module. And this is automatically resolved by the module system at startup time. So it tries to see, okay, whatever module do I need to run the CLI module? Oh, well, I see that I need the analysis module, so it will look up in the module path if there is an analysis module. And we can even see that if we delete this analysis module and we try and run the same application again, it actually yells at us during startup time rather than at runtime with some class dev not found exception or whatever. In this case, it says, okay, there is an error and there's a module, there's a resolution exception. We cannot find module analysis. So that's a really, really big improvement over the class path case. And we've also seen that using the exports and requires, we have explicit information about what is visible between modules. And using the module graph, we have both compile time and runtime support to actually better structure applications. So let's move back to the slides for a second again and talk about a different problem. Because what we've seen here is that we can control what we expose and we have explicit dependencies, but still I was talking directly to this flash KK class, which sort of sounds like an implementation detail. What I'd rather have is that my CLI module talks to some kind of interface, some analysis or analyzer interface, and this interface should be the only thing that I know about as the CLI module. And whatever implementation there is, I don't care, just get it done. But there's a problem, because as a CLI module, even though I can introduce an interface, I still need to get a hold of some implementation. And normally you would do that by instantiating an implementation like here. But if you do that, then you need to also have access to this implementation class. And it needs to be exported to you, which is something that we really don't want. So the big question here is how to use an implementation without having to have access to it. Well, we all know about dependency injection, inversion of control, and as a general pattern, that's the solution to this problem. So what we really would like to have is some provider module registering a service under an interface into a service registry, and a consumer module, like my CLI module, would somehow query this registry and get an implementation but it doesn't have to know what kind of implementation, just needs an instance, as long as we know about the common interface. So fortunately, that's what's also possible in the Java module system. So this is called the Java module system services implementation, and it's actually something that's already part of Java for a long time. It's a mechanism that's not that widely known, but it has been refreshed for the Java module system, and it looks like this. So let's say we have a module myAPI containing the interface that we're concerned about, the interface that we want to share between the provider and the consumer module. And we have a module myConsumer, which obviously has to require myAPI because it has to know about this interface that we want to use. But there's also an additional statement here, which says uses API myService. And this expresses to the module system that I'm interested in any instances of the interface API myService. Now, of course, we also need a provider. And again, the provider needs to require the API module because it contains the interface, and the provider needs to implement the interface. And then there's another statement in the module info which says, okay, this module provides an implementation of API myService with my provider myService impl. And the interesting thing here is that the myProvider package isn't exported from this module. So it's not visible to the outside world. We cannot ourselves instantiate myProvider myService impl, but we give the ability to instantiate it to the services mechanism of the module system. Now, the last piece of the puzzle that's missing here is, okay, how do you actually get a hold of these instances inside your consumer? And there you are going to use the so-called service loader API. And it's fairly simple. You say service loader load, and you give the class of the interface, in this case myService.class, and you get back an iterable with any instances that have been registered as implementation by any provider modules. So this way, you get a loose coupling between the provider of an interface and the consumer of an interface. And while this pattern is fairly common in external frameworks, it's now also possible to express this in core Java. So let's see how that looks in action. And for that, we're going to look at easy text again, but in a slightly more elaborate example. And the example actually tries to convey two things. One thing is that we can have multiple modules talking to the same analysis backend. So we had a command line interface, so let's add a graphical interface as well. And there we can see that even though the command line interface only used the Java base module, which was, by the way, an implicit dependency. You never have to mention that because you cannot actually write any code without Java base. But the GUI is written in JavaFX, which needs more modules from JDK. So we'll see how that looks like. And we're also going to look at an implementation of the analysis algorithms using the service API. So what we want to achieve is that we have multiple implementations of such an analysis algorithm. And we're going to decouple the front ends from the back ends through the service loader API. Before we dive into the code again, let's look at how that looks in a diagram. So we'll get an API module containing just the analyzer interface that we're interested in. And only the CLI and the GUI modules will depend on this API, of course, because they need to call into it. But they do not depend anymore on the concrete implementation modules of the analysis algorithms. So we had Kincaid. We're going to add a Coleman analyzer, which is a different way of analyzing text complexity. But there's no requires relation between the front ends and the implementation modules, which is what we wanted to achieve. Also note that the GUI module has a dependency on two modules that come from the JDK, in this case JavaFX graphics and JavaFX controls. So it's also clear there what's exactly used from the JDK itself besides the base module. Now, of course, there is a relation between the front ends and the implementation modules, but that's decoupled through the services API, as we will see in the example. So let's go to the code again. Now, we have quite a bit more modules in this example. Like I said, the GUI, CLI, and as you can see, we have the API containing the interface and the two implementation packages of the analysis algorithms here. So let's first take a look at the GUI main. So as you can see, we import quite a lot of JavaFX types, so we need to do something about that in our module info. And then in our main method, we somehow have to load the services. Now, we can use the service loader API to do that. And we can load any implementations of the analyzer class, and those will be used in the GUI to show a choice of analysis algorithms. So just to make it perfectly clear, it's a normal Java interface containing a get name to get a description of the name of the algorithm, and it has must have an implementation for the analyze method. So going back to the module descriptor for our GUI, we can see that we need to require those two JavaFX modules from the JDK itself, and we require the API because we need to know about the analyzer interface. But we also need to declare that we use the analyzer interface to the module system service loader. So we're going to do algorithm API analyzer like this. And let's try and run this. So I created a little script just to save some typing. And what happened here is that we compiled the application, we created jar files, and we ran it. But there should have been a choice of analysis algorithms here, but it's empty. And you might be wondering, okay, so why is that? Because we did declare our users here. And that's because in the implementation modules, we still need to provide information about which class we want to register. So in this case, we provide the Java Modularity easy text algorithm API .analyzer interface with Java Modularity easy text algorithm, and we're in the, let's see, Coleman analyzer, so Coleman analyzer, and let's directly do the same thing for the Kincaid analyzer. And as you can see, this one itself also uses another service, so there's no need to be shy with that. You can at the same time provide and use services yourself. And in this case, we need to give another implementation like this. And if we run again, we should be getting an actual selection box where we can select between the two different algorithms. So obviously, it's not going to be very interesting, but so we can choose between different implementations, and just by virtue of registering a service, you will get an additional algorithm here, which makes it a very nice model and a very decoupled model. If I were to add a third implementation, I would only have to add this module to my module path, and if it registers a service under the same interface, it will be found by both the GUI and the CLI modules, and it will be usable in that way. So once more back to the slides, because there's also a new phase introduced into Java development. It's an optional phase, and besides the development and the runtime phase, you can use, if you want to, a linker. And I don't know if there are any hardcore C++ developers here who might be going nuts now or thinking, oh no. But anyway, it's a nice addition to the toolchain. So what you get is a tool called JLink, and you can use that to create a so-called custom runtime image, which is essentially a Java runtime that includes your application modules and any modules from the JDK that your application modules need to run, and nothing more than that. And it can construct such an image because we have explicit information about all the dependencies between modules. Like you saw in the example, I had to define that I used those two JavaFX modules, for example. And using this information, it can create a module graph, which is the smallest graph possible to run your application. And once you create such a runtime image, you can, for example, use that as something you distribute, or you can use it as basis for your Docker images, or any other way that you want to use this. And obviously, it will be a smaller image than just installing the whole Java JDK runtime and then running your application on top of that. The other nice thing about this is that it's actually a point where we have so-called possibility for so-called whole program optimizations, which is fairly unique because in the old classpath times, you really didn't know what was actually used in the application and what wasn't used. So I think it's a very exciting opportunity for Java development because it's such a new area. These plugins, these optimizations will be plugin based. So I think the JDK team will bundle some common optimizations, but this is really something that needs to be explored in detail once the module system is out. So you can think of optimizations like dead code elimination, inlining across different modules, etc., which is only possible if you have the whole view and if you have explicit information about what module is using which other module. So that was the final demo that I want to show you. What would it look like if we were actually going to link our EasyText modules into a custom runtime image? So let's go back to the EasyText example with the modules that we just saw. And I'm going to call JLink, like we have here. And I'm giving it a module path containing the modules that I just created when compiling and running the application. And I'm giving it the path to the modules that are inside of my JDK itself to resolve any platform modules, any modules that are part of the JDK itself. And then I can add so-called root modules. And in this case, I want to, of course, add the CLI module, and it will add the CLI module to the runtime image and any dependent, modules it depends on. But as you can see, I'm also adding some additional modules, and those are service implementation modules, service provider modules. As it stands, the current Jigsaw system uses the requires relations to build this image, and it doesn't yet look at the uses and provides. And there's some discussion going on whether that's going to stay that way or not, but anyway, currently the whole services part is more dynamic, and you have to select yourself which service implementations you want to bundle. But the requires relations, yeah, those are really modules that are necessary to run and compile your code. So what I'm doing as well is I'm stripping debug symbols and I'm outputting it into a directory called image. And once I do that, I get a directory containing a bin, conf, and lib folder and a release file. And this is actually a self-contained Java installation that has just enough modules installed to run my application. And it even created a binary file, which I can invoke like this, without ls. And it runs the application without me having to define any module path or other things at the command line. And if we look at the directory a bit more in depth, we can see that it contains this Java Modularity EasyText CLI command line binary, and it also outputs a Java command and the key tool commands, just because in Java base there's some security stuff which can use the key tool. But we can also run the Java command in here directly and ask it, okay, what modules are in this runtime image? And you will see it's only the Java base module plus the modules that are defined at link time and any additional modules that were resolved. For example, the API module was resolved because it's used by the CLI module. So it has done this automatically for me. Looking at the size of this image, it's 28 megs, which is still fairly sizable for a command line application, but it's far smaller than whole JDK to run just this application. Now, if we do the same for the GUI, in this case, it's working for a bit longer because it has to do more work, because we're using those two Java FX modules from the JDK. And if I list the modules that are in the image right now, you can see it has the Java FX modules plus all their own dependencies, which are, well, I'm not going to list them all, but it's more than we had in the CLI example. So here you can see the difference between a small command line application, and let's look at the size just to compare as well. Now it's grown to 75 megs, which is, again, already fairly sizable. So using this tool, you can create minimal images, and you can create just enough runtime environment to run your application. Okay, so this brings us back to migration.
Great. So hopefully this shows that it's fairly easy to get started with Java 9 and working with, well, kind of new modules and using those new keywords to design your application in a more modular way. But of course we all have existing code. And how do we ever get from this old classpath world to this new world module path? Because that's going to be challenging. Now there's a few things that we can do for that. The first thing that you should probably do today is analyze your source code using JDEPs. There's just a tool that can tell you if you're using any kind of internal JDK classes, or that you have any libraries that use internal JDK classes, because that's going to be a problem. And you might want to start migrating or looking at alternatives. There are still some escape hatches that, well, are kind of a last resort if you really need to, well, work around the encapsulation that the JDK now offers. But then more importantly, once we know about, well, our application and we see that there's not really any big problems, how do we move our source code to this more modular world? Because we have seen that the class path in the end is just gone. So how do we deal with that? And for that there's a mechanism called automatic modules, which is the migration tool to take existing code and well, partially migrate it to modules until you're ready to migrate fully to modules. So let's take an example. You have an application which is demonstrator.jar, it's packaged in a jar, and this demonstrator.jar requires another library that we have, commons lang, and it of course also uses Java. So I want to migrate this code, the code in the demonstrator.jar, to be a module. Well, this is the code that we have, so it's very simple. Well, from the NPM world, we learned that left path is probably a very good reason to drag in some kind of external dependency. So that's what I do. I use commons lang for that. And if I would just want to run this using Java today, I would use the class path both during compile time, putting the commons lang library on the class path, and I would do the same thing at runtime, again, putting my own code and commons lang on the class path. This is how we would run it today. But of course, now I want to migrate this code to be inside a module. So I want to take my code and move that to the module path. I should, of course, make a module descriptor for that, but then I want to move it to the module path. Well, tough luck, that's not going to work. Because if you're on the module path, it's impossible to load types from the class path. And as long as commons lang is still on the class path, I can't see it, I can't access it. So that's a problem. And the only solution to that problem is, well, I have to move that library somehow to the module path. But then you can say, well, hold on, I'm not a maintainer of commons lang, and probably I have 50 other dependencies, and I don't want to go into their source code, add module infos and make them libraries, just so that I can move to the module path. That would just be too much work for a serious application. And that's where the automatic modules come in. So an automatic module is just a plain jar file as we have today, without any kind of module metadata. But instead of putting it on a class path, we just put it on a module path. And it will automatically put it, or transform it to an automatic module. And an automatic module is a module that has a module name which is derived from the jar name. So they basically take off the version and replace some symbols that are not allowed in module names. So that will be the module name. That module will export everything. So, it's doing very badly if you look at encapsulation because it's not actually doing any kind of encapsulation. But at least you can use it. And it will read all other modules. So if commons lang, for example, loads other types on a class path or on a module path, it can actually still do so because it reads all other modules. Then you might say, well, you just said that you can also read stuff on a class path, but that's not a module, so how does that work? Well, looking at automatic modules, there's an exception to the fact that normally you can't see the class path, and that's in the form that the class path is also actually a module, the unnamed module, which contains everything on a class path. You can't use that from named modules, but you can use that from automatic modules, just as a migration step. All right, so how does that work? First of all, I have to write the module descriptor for my code. And in that module descriptor, I have a require for another module, commons.lang3. And as we have seen, that's not actually a module. But we can turn it into a module by just moving that commons lang jar file to the module path. So this is just something that you have to pass into the Java command and the javac command. And that's it. Derived from the name of the jar file, we get this common lang3 library or module. And we can just start using it as if it were a fully modular jar file containing a module info. So that's pretty good. Because this way, we can actually take our own code and start moving that towards the module path and start using the module keyword, etc., to actually make a more modular version of our code without having to wait on all the library authors to move their code towards Java 9. So it just makes it much easier to just take your code and move forward without waiting on the rest of the world. So that's very good news. So looking at the state of Java 9. As I said, it's getting close to being finalized. We should be getting a code freeze very soon. It's not announced yet, but it should be very soon, looking at the timelines. But there are still a few open issues, and these are design issues. Not so much implementation issues, but design issues. For example, there has been questions on the mailing list about optional dependencies. Currently, the prototype doesn't support optional dependencies. You have a dependency or you don't. And there's nothing in between. And of course, for frameworks like, for example, Spring, where they rely on the fact that, you can put some extra library on the class path, and if it's there, then we start using it. If it's not there, we just do something else. That whole mechanism doesn't currently exist in Java 9. So there's still discussion going on, how are we going to deal with this? And probably this is one of the issues that they will actually come up with some kind of solution. Versioning is another topic. Java 9 doesn't actually support versions. You can put a version on a module, but that's just metadata. It's not used in the resolving steps, and it's left to build tools to actually, resolve. So if you have ideas about that, I strongly recommend actually giving feedback on the mailing list. The mailing list is pretty active, so that's very good. There's still work going on there. Okay, so looking back at what Java 9 is supposed to promise and the goals that Java 9 is supposed to solve. Well, one of the things that is going to happen is that modularity is finally going to be a part of Java development for everyone. And that means that tooling support will actually be there. Well, all the tool vendors are already working on it. Maven and Gradle support is coming. There's already some support in Maven, actually. The compiler plugin supports Java 9 now. So that's all getting there, and that's very important because that's actually going to be the big difference between using something like OSGI today, which always is kind of, half working if you look at the tooling, etc. And this is just going to be, part of everyone's development. And that's very good. So at the very least, it's going to put a spotlight on modularity. And because modularity is a very important concept when you look at design and architecture, this, if you ask me, is a very good thing. As I said, Sandra and I are working on a book for O'Reilly about exactly this topic. It's scheduled to be out just before the Java 9 release, so as it stands today, it should be somewhere early 2017. We have a Twitter account that you can follow about to track news about the book and some general Java 9 news, so I recommend you doing that. And with that, that's all we got for today, so if you have any questions, then now is the time.